Okay, so moving on, Sir Odds, we have the auto reelers now from ST Microelectronics Incorporated Calamba to present improvised automated lot preparation table at micro module test and finish line.
Okay, auto reelers, take it away.
Pagising ni Marlon, kinabukasan.
Aroy, kasakit ka ng balikat ko. Parang hindi ko yata kaya pumasok ngayon. Makatawag nga sa bisor ko. Hello, sir. Hindi ako makapasok ngayon. Pagkasakit ng balikat. Gawa yata ng manual rotation dyan sa lot prep.
Ay gayong ga. Ay siya, sige. Ikay magpahinga muna diyan at ako na lang ang maghahanap ng kabilit mo din ay. Hello, Rejay. Pwede ka gang mag-extend para mag-manual at preparation. Naka-SL si Marlon ay.
Sige ho, sir.
Paring Julius. Ano bang pwedeng gawin natin diyan sa lot preparation process? Parating nananakit ang balikat at likod nila ay.
Tigat manual rotation yan.
Wow.
Sige, huwag kang mag-alala at gagawa natin ng isang innovative na solusyon iyan para maiwasan na ang pagsisiklib nila. Innovation is a state of mind. It is commonly defined as an out-of-the-box thinking, using resources on hand into useful tools or solution with a breakthrough results. To support our BMMT vision in offering winning solution, being innovative, fast, and simple, we present the improvised automated lot preparation table. We are from ST Microelectronics, belonging to the business unit of Back-end Manufacturing and Technology Plant, which has various manufacturing sites worldwide. ST Philippines is located at Light Industry and Science Park 2, Calamba, Laguna, Philippines, and we are certified to several international standards. We sort, assemble, and test integrated circuits and modules through innovative, fast, and cost-effective solutions by putting our core values of integrity, people engagement, and excellence in our actions. I'm Julius Andal as the leader of the team, and my members are Alvin Serenilla, Reggie Buno, Marlon Sabio, and we are guided by our team advisor, Ms. Marichu Amalin. Our team was formed June 2017, which composed of 3 technicians and 1 production operator from manufacturing assigned at micromodule assembly to finish line with a common goal to find an opportunity for improvement. So our judges, everyone,
We are the auto reelers.
our team formulated this time plan which guide us on the progress of each step wherein all aspects are accomplished according to plan. Safety first. This reminder drive our team to focus on the prevention of accidents and hazards on the manual lot preparation process under the BMMT 2017 annual priorities under manufacturing which promote safe workplace. This is the micromodule process flow composed of frontline, test and finish, and where our innovative improvement focus on the manual lot preparation process.
What is the manual lot preparation process?
It is the first process step at test and finishing of all device at micromodule line, which covers quality check and preparation for the next process, which is automatic visual inspection.
What is a manual lot preparation table?
It is composed of air ionizer blower, a microscope, gray film tape with input and output mechanical spooler, where the operators perform the manual lot preparation process. Let's see what the operators do on the manual lot preparation process. On this video, the 2 operators perform repetitive manual rotation of metal reel while inspecting the previous process and to get both end of the lot to attach the 1.5 meter gray film using splicing tool. To further analyze the lot preparation step, here is Marlon.
Thanks, Julius. There are 5 major steps in lot preparation process. First step is the loading of input metal reel into input mechanical spooler. Second step is the leader film attachment, wherein the 1.5 meter gray film is attached start of the lot using splicing tool. Third step is manual unwinding and tape splicing, wherein the thermal tape from previous process is respliced using splicing tool. Fourth step is the trailer film attachment, wherein the 1.5 meter gray film again is attached at the end of the lot using splicing tool. The last step is final rewinding, wherein the input metal reel is rotated counterclockwise to wind up the reel type device. All these major steps are prone to potential physical hazard. So we do the job hazard analysis with the rapid entire body assessment to identify this hazard per lot preparation step. For step 1.1, loading of input metal reel with potential hazard to man, possible hit the operator, potential defect of material, scratch tape. For weight comparison of one lot, it is comparable to 11 kilogram of one liquefied 11 kilogram liquefied petroleum gas. For step 1.2, leader film attachment to potential hazard to man, hand pinch, potential defect of material, scratch and dent on contact side. For step 1.3, manual unwinding, tape splicing, potential hazard to man, back, shoulder, and wrist injury, with potential defect of material, scratch tape, and crumpled tape. For step 1.4, trailer film attachment, potential hazard to man, hand pinch, potential defect of material, dent, and scratch on contact side. And for the last step, 1.5, potential hazard to man, back, shoulder, and wrist injury, potential defect of material, scratch tape, and crumpled tape. For the reverse scoring, for step 1.1, 1.2, 1.3, 1.4, 1.5, it falls down to medium risk. While the step 1.3, because of manual unwinding and tape splicing, it falls down to very high risk and need implement change. For continue, here's Alvin.
Thanks, Marlon. The graph shows the number of lot process at lot preparation corresponding to the number of repetitive manual rotation. From there, we saw an opportunity for improvement. And our opportunity statement is to eliminate the repetitive manual rotation of metal reel during lot preparation process at micromodule test and finish line. To realize our opportunity, our team big idea is to improvise an automated lot preparation table capable of automatic winding and unwinding reel-type device. We use the force field analysis to help us identify our driving forces and restraining forces that may hinder us from obtaining our ideal state. We have identified 7 driving forces and 6 restraining forces, which means that the potential gain is greater than the forces against the ideal state. Therefore, if we were able to overcome our valid restrainer, we will able to achieve safety on our people on top of the cost savings gain for the company. This is our team validation on our restraining forces. And out of 6 negative restrainers, only 2 valid or true restrainers were identified. This is the design functionality constraint if purchased from local vendor, which is within our team control, and the budget constraint, which is beyond our team control. Therefore, our team objective is to eliminate the design functionality constraint on the design of lot preparation table on winding and unwinding the reel-type device at micromodule line by end of August 2017. For the selection of best alternative solutions, error-proofing methodology was used to qualify solutions that improve the manual lot preparation process. We also define a set of criteria for proper selection of best solution among the alternatives and categorize each best solution as novel, innovative, or benchmark. We have identified and validated 3 alternative solutions to address our valid restraining forces. For alternative solution number 1, use of another BMI table for lot preparation process. Result, eliminated the repetitive manual rotation of metal reel but need to manually index the tape. Also, stretch tape was observed due to motor over-rotation.
This is not an effective solution.
Team decision?
No go.
For alternative solution number 2, use of AC motor with speed controller and driven by sensors. Result, eliminated the repetitive manual rotation of metal reel, but still, stretch tape was observed due to motor over-rotation.
This is not an effective solution.
Team decision.
No go.
For alternative solution number 3, in-house fabrication of lot preparation table using AC motor with brake and sensors. Result, eliminated the repetitive manual rotation of metal reel and no stretch tape was observed.
This is an innovative solution.
Team decision.
Go!
For the potential problem analysis, here is Reggie.
Thanks, Alvin. Before we implement the chosen best solution, we identified the potential problem and its potential causes and defined counter-preventive measure to address potential causes. The PDCA, or Plan Do Check Act methodology, was used by our team to ensure effective execution of our best solution. Before, the lot preparation process is a purely manual wherein the 50 times repetitive manual rotation of metal reel is done by 2 production operator, which could lead to several physical hazards like shoulder pain and back pain. This video will show the result of our team effort and dedication. To improve the quality of life, the innovated lot preparation table improves safety on the lot preparation process by eliminating the repetitive manual rotation of metal reel done by production operators. It is also a cost-saving project because majority of the parts used are available in-house. This project considered innovative as it was improvised from a normal working table transmute into an automatic self-winding and unwinding lot preparation table with motors and sensors. For the solution implementation of best solution for step 1.3 and 1.5, before, potential risk of back, shoulder, and wrist injury due to repetitive manual rotation of metal reel on the lot preparation process. After, eliminated the potential health hazard of the repetitive manual rotation due to the capability of the best solution of self-winding and unwinding reel device type. For the solution implementation of best solution for wrong winding due to human error, before, prone to wrong winding because operator is the one who controls the rotation direction. After, eliminated the wrong winding because the motor has only one direction counterclockwise. For the solution implementation of best solution for manual stop using hands, before, operator use their hands to stop rapid rotation of metal reel, which is potentially on wrist injury and also prone to stretch tape. After, eliminated the potential wrist injury and potential stretch tape to the product because of the automatic stop feature of our best solution.
Innovative solutions, indeed. But what are your breakthrough results?
These are the summary of our breakthrough results. Remember, step 1.3 is at very high risk level and now improves to medium risk level with 54% improvement. For step 1.5 is at medium risk level and now improves to negligible risk with 83% improvement. Next, before, 2 operators do the manual lot preparation. After project implementation, 1 operator is required to do the process and the other operator is now full-time on machine operation. For safety, we had 0 out the number of sick leave related to ergonomic illness, and also we sustained 0 occurrence of accident and near miss. And lastly, we have a cost avoidance of $10,000 through the use of scrap machine parts. For other tangible benefits, here is Julius.
Thanks, Reggie. Our team won Gold Award during the QIC Plant Finals last November 2017 under Easy Kaizen category. And this innovative idea was recognized globally in the ST Annual Global Recognition for 2018 Star Awards under Best Suggestion category. The recognition didn't stop there. We won another Gold Award in the last QCRC competition last August 2018 here at Crimson Hotel. These are our team learnings. We have gained competency in automation, additional knowledge in the AC Kaizen tools, and improved in the aspect of leadership, commitment, and teamwork. For our standardization, we have completed all the document updates and the training regarding the automatic lot preparation table on a micromodule test and finish line. Our innovative thinking didn't stop here. We are currently fabricating another lot preparation table with auto-lifting capability and to install with much faster gearhead ratio to improve the winding and unwinding process time. Seeing our innovative idea helps our co-workers in their daily task is already a success for the team. Because in ST Calamba, we believe in the future and we make it a reality today. This ends our presentation. God bless us all. Thank you very much. We're now ready for your questions and recommendations.
Okay, thank you.
Okay, thank you very much. Sa gitna raw muna kayo, photo ops, bago kayo tanungin, bago kayo gisahin. Okay, questions? So yung mga nandito last time, nakita nyo na rin sila kasi second time na raw nila sa Crimson eh. Di ba? Peter.
Auto reelers, good job indeed.
Thank you, sir.
I like it that you narrated your continuous improvement journey very clearly. I am very sure everybody in this room learned a lot from you. Kudos.
Salamat po.
Thank you, sir.
Kala ko may tanong ka. It's just a compliment. Very good compliment. All right? So, here comes the real question.
It's just a clarification. Have you considered the mini sizes of reels? The small one? I saw the bigger one. Have you considered the small ones?
Salamat po sa katanungan, sir. Sa process po kasi ng micromodule is from front line, gumagamit po sila ng maliit na reel. For example, is in die band, wherein the bare coco tape. So maliit po siyang reel. Pagdating po dito sa test and finish, kasi po yung dami po nung reel o yung haba niya, is yun po talaga yung naka-design na size nung reel para sa that amount or yung length nung product po.
Tsaka sir, for additional sir. Kasi sir, yung process sa bago yung lot prep, TMC po, kailangan po namin doon bakal na reel ang gagamitin. Yung bakal na reel po, 55K po ang capability po ng isang reel na yung kaya ganun po kasya kalaki. Yun po ginagamit.
Additional lang po, sir. Customer requirement po kasi, sir, is 50K pataas yung quantity nung ano nila. Yung quantity ng i-deliver namin sa kanila. So, yung 50K po na units, ganun, hindi po kakasya sa maliit na reel kapag during sa processing.
May sasabihin pa yung isa. Kasi lahat kayo sumagot eh. Siya na lang yung kulang. Wala na. Nasagot na, nasagot. Okay. Follow up daw. May follow up. Para dun sa last.
How do you control the speed of the reelers?
Sir, actually yung reel po is yung upper po na gearhead niya, ang ratio po niya is 180:1, meaning 180 rotation of the motor, 1 rotation of the gearhead. So yung ilalim naman po is 90:1. So nakapix po yung kanya, yung bilis po niya because of the gearhead ratio.
Follow up pa ulit. May bayad na yan.
So you have a fixed speed, no? Kasi how do you now, back to my first question, control with a many variety of reels in the input? You have one reel output, right? The big one. But in input, you have varieties of sizes.
Sir, sa input po, is sa upper side po is same the size of that reel. Sa ilalim po is nakapix din po yun. That is for spacer collect and spacer feed. So yung nilalagay po nila sa input is same size din po nung nasa output reel.
Okay. So, same yung input and output. Okay.
I guess we can entertain one last question
One
po
last
from our
question
audience.
here. Sir, pasensya na ha. Meron dito eh.
Okay. Good morning, team, and thank you for your innovation related to sa ma-resolve yung ergonomic issue nyo. So, for manufacturing, it's very important na we help our operators na ma-lessen yung mga lifting or yung mga ergo issues, especially kung aging niya yung population. So, you zero out yung sick leave. Ano kaya yung impact natin sa attendance? Isa sa KPI ng manufacturing is yung attendance. And second question is, how do you validate na yung sick leave nyo is really coming from the ergo issue ng operation? Kasi isa rin yung sa factor na difficulty ng leaders to validate kung yung operators nila is really telling the truth na yung issue nila ng body pain or kung ano man na ergo issue is really coming from their work. So medyo difficulty ng manufacturing din yon kung ano yung dapat i-resolve doon.
Thank you. So, maraming question yun.
Thank you po sa magandang tanong. Bali po yung question yung una, yung sabi nyo, paano na yung KPI ng tao, mas maganda na po yung attendance ng ano kasi nga, bihira na yung absent nila dahil doon sa pagsakit ng balikat. Yung second question nyo po, paano namin na-validate yung bakit, paano na sa balikat yung sakit nila. Kasi sila rin yung nagsabi sa amin na kailangan ng kung pwede daw namin improve yung may pwede daw kang gawin para may iwasan yung pagsakit ng balikat kasi hirap sila mag-ikot talaga ng metal reel. Kung gaya yung sinabi ko kanina, yung bigato ng metal reel, 11 kilograms, halos yun. Opo, parang ganon. Sobrang bigato nun kung iikot mo manually. Kaya yun, yung paling yun nila. Sila yung may nag-ratio sa amin para magkaroon ng idea sa ganon improvements.
Okay.
Additional po, yung tinatanong nyo po na kung nako-confirm ba namin kung talagang dahil doon nag-ESL yung tao, siya po yung magpapatunay kasi siya po yung operator doon sa...
Yung operator doon.
Alright. Okay. Okay, thank you. Okay, again, kung may mga questions kayo na hindi na accommodate ng time, you're always free to ask them later on. Thank you very much.
Thank you. That is one neat presentation from our auto reelers with concern sa manpower nila. Is our next team ready kaya?
Siguro maraming kumukuha sa inyo ng skillan, no? Masakit yung balikat at saka
Okay. So, I heard, sir, ready na yung ating susunod na team? Okay. Our next team is QFN 3x3,
Hello.
still from ST Microelectronics Incorporated, Calamba, to present handler alarm reduction on Epson handler at QFN 3x3.
Hello.
Hello. Once, a famous scientist said, necessity is the mother of all inventions. Technology is now a necessity in our daily lives. Technology evolves on transportation, communication, lighting, computers, data storage, and many more. We are striving in finding ways to continuously improve and bring in the new in our daily lives. ST Microelectronics Calamba is proud to present to you one of its success stories on machine improvement. Dear panel of judges, presenters, colleagues, and to the project mentors, good morning to all of you. ST Microelectronics Calamba is a back-end manufacturing and technology plant located at LISP2, Calamba City, Laguna. We sort, assemble, and test integrated circuits and modules through innovative, fast, and cost-effective solutions. We are the benchmark of manufacturing excellence, guided by ST principles of integrity, people engagement, and excellence in action. Here are the men behind this project. Erwin Martinez, our team leader, and the team members are Samuel Santa Rosa, Joffrey De Torres, and yours truly, Erwin Del Rosario. And we are the QFN 3x3 team! Our team was formed last July 2016, and a project charter was then created to start the journey of our team to reduce the high incident rate of machine jam at QFN 3x3 that is linked to equipment efficiency, quality, speed of delivery, low in manufacturing cost, and setup effectiveness. Our team used the 5 phases of the MIC methodology, and we are guided by this project timeline wherein every activity is monitored for completion according to the plan. Our project is rooted from back-end manufacturing and technology plant, Calamba 2016 policy deployment that is driven by 2016 annual priorities of revenue growth, invest for growth, manufacturing, and defined by 2016 test and finish flag diagram that is linked to effective use of assets for manufacturing. The final test NEE was not being met at an average of 80.4% versus the target rate of 82.5% in Q2 of 2016. Using the project definition 3, net equipment efficiency per platform, we were able to identify that the lowest NEE performers are Advantest, A565, and ETS tester platform, with an average of 70.85% contribution in Q2 of 2016. Continuing on the next level of down mode, it came out that the handler down is the top contributor, with an average of 5.91% in Q2 of 2016. Digging further on the type of handler, it came out that Epson NX6040 is the top contributor, with an average of 72% in Q2 of 2016. While on package level, it came out that QFN 3x3 is the top contributor, with an average of 52.78% in Q2 of 2016. Handler down on QFN 3x3 was monitored through MUBA performance. Low MUBA or mean unit between assist, wherein the 5K MUBA target was not being met, at an average of only 3,707 units in Q2 of 2016. Digging deeper on the causes of low MUBA, here's the Pareto of errors, and it shows that shuttle and index jam are the main reasons why we have high incident rate of machine jam on QFN 3x3, running on Epson and the 6040 with an average of 232 jumps per million units in Q2 of 2016. And this should be resolved by our team. To continue further, here is Geoff.
Thanks, Erwin. Let me give you an appreciation of final test process. Handler is a machine that handles the integrated circuits and sends start-of test signal to the tester. Tester is an equipment that tests the electrical functionality of an IC and send bin result and end of test to the handler. Handler has a conversion kit, a mechanical hardware installed in handling ICs. It consists of input and output pickup, input and output shuttles, duct plates, plungers, and hot plates. Handler and tester are integrated with load board, socket, duct plate, and linked by the docking system. Here is how device handling and testing works. Untested ICs are loaded in input loader. Input arm picks the untested IC and then places the input shuttle. Input shuttles moves to the index arm. Index arm picks the untested ICs and then plunges to contact site for testing. After testing, the index arm places the tested IC into the output shuttle and then sorted out by output arm based on the bin result provided by the tester. Let me give you an understanding on handler jam sequence. Device floating jam happens when the input shuttle sensor detected the IC that is not properly seated in the shuttle packet. Device pickup jam at input shuttles 1 and 2 happens when the IC is not properly picked up by the plungers. Index arm device drop jam. The IC was picked by the plungers but it was dropped during travel or after plunging at contact site area. Device place jam happens when the IC is not present or tilted during output shuttle transport at output area. To find out all the possible causes, we used the input and output worksheet. We were able to identify 18 controllable input variables. Applying the cause and effect matrix, the 18 controllable variables were trimmed down to 8 based on the rating on impact on handler jam and customer priority. Our team reviewed the equipment failure mode and effect analysis to check if there are existing controls to detect the input variables on influence to output variables. Among the top 8 input variables from the cause and effect matrix, we perform quick wins activities on the 6 inputs that have low risk priority number. We then continued to focus on the top 2 RPN, which are the plunger nozzle tip height and the plunger pressure condition. Both have been subjected to statistical analysis to validate its significant contribution to index and shuttle jams. Thus, we define our problem statement as high occurrence of shuttle and index jam on Epson machine for QFN 3x3 with an average of 232 jumps per million units from April 2016 to June 2016. To continue, here is Sam.
Thank you, Job. On analyze phase, our team used two proportion tests to confirm the two different nozzle tip height. Based on the statistical test result, plunger nozzle tip height with 0.2 mm produces less jam than 0.5 mm tip height. For the comparison of plunger design, based on the results, the new design produces less jam than old design. For that, and this was the plunger design is true cost and within the team control. With all validated causes team control, the final, this is the objective to reduce occurrence of shuttle index jam on Epson machine at QFN 3BRT products from average of 232 jam per million units to 69 jam per million units. For two true causes, we brainstormed three alternative solutions. Error proofing is one of our guides for the selection of best alternative solution, where error proofing level 1 is error elimination, EP level 2 is error prevention, EP level 3 to 5, detection level from source and post-process. Other guides are effectiveness of solution, cost of implementation, risk, safety, and delivery with equivalent rating. The alternative solutions were categorized according to novel, innovative, and benchmark. Shown is the alternative solution matrix. Method to verify alternative solution effectiveness, results verification effectiveness, and limitations seen on the proposed solution. Categorize according to method, results attained, and rank accordingly. Go to implement solution, and no go to discard alternative solution. We identified three alternative solutions. For nozzle material, we changed from PEEK plastic to stainless material. Results, produces frequent jam. For the team decision,
No go.
For nozzle tip height, we reduced nozzle tip height from 0.5 to 0.2 mm. Result, reduced machine jam but did not meet the target of 69 jam per million units. For the team decision,
No go.
for the plunger, we redesigned the plunger. Results, reduce machine jam to an average of 65 jam per million and eliminate consumption of plastic nozzle. Before we conducted, the team decision, go. Before we conducted potential problem analysis, we conducted potential to identify the potential problem and to identify the potential problem. Here are the project implementation timeline and set according to plan where we set the target date. Do where we set the target date and where we set the target date and person responsible. Check where we recorded the learning and carrying status to ensure that the plan is obtained. Act where we recorded the learning. Let me show you the solution of our solution for high occurrence of shuttle index jam with average of 232 jam per million units in Q2 of 2016, the redesign of plunger. Now I will show you the tangible results of our endeavor.
Thank you, Sam. For results verification, before shuttle and index jam average of 232 alarm jam per million units, and after implementing the improvement actions, shuttle and index jam were reduced on average of 65 jam per million units, equivalent to 72% improvement, and achieved the team objective. The QFN 3x3 Epson handler MUBA performance was also improved from an average of 3,707 units to 13,044 units and hits the 5,000 MUBA target. The handler down was reduced from an average of 5.91% in Q2 of 2016 to 4.04% in Q4 of 2016 with 1.87% improvement. The NE at Advantes A565 and ETS tester platform was also improved from an average of 70.85% in Q2 of 2016 to 73.85% in Q4 of 2016 with 3% any improvement. With this, our team gained a total cost savings of 10.9K USD, and it was certified by our plant IE. For intangible benefits of our project for employee, we gain additional knowledge and learning, develop the way people think, and out-of-the-box thinking, and gain can-do, will-do attitude. And for environment, eliminated the scrappage of plastic parts, reduced metal scrappage through recycling of old plunger pressure parts. For the standardization of our project, the team updated the equipment FMEA, process change management system, and spare parts procurement. This project has paved the way to improve all other package family as we were able to pan out this new plunger design to all Epson machine. In order to assess our team progress, our team used these relevant characteristics as our reference for self-assessment. Our team improved from 2.9 to 4.4 as a whole, equivalent to 52% improvement. What went well to the team is to share our expertise to each member, and to the team improvement, we need to undergo subject matter expert program and also acquire phenomenon mechanism analysis. Shown the team future plan, members now leading other improvement project. Before we end this presentation, here another quote from Albert Einstein. We cannot solve our problem with the same thinking we used when we created them. We thank God for giving us the strength and knowledge to meet our targets and reach their spar. Thank you. But wait, there's more.
Napakadyan mo pala, plastic na selpangit ka. Sinubukan ng stainless material, ngunit ito'y hindi naman umubra. Ibinalik ang plastic na material, haba ng sukat binawasan. Subalit resulta ay kulang pa rin, kaya kailangan talagang baguhin. Plunger nozzle baby, no nozzle baby, ito talagang okay. No nozzle, no nozzle, no nozzle, talagang okay.
Okay.
Alright.
Thanks po. Question lang po, ano po yung material po nung plunger nyo na ginamit po?
Hello. Stainless steel.
So concern ko lang po is tinanggal nyo po yung nozzle, which is nagko-contact po dun sa unit. Meron po bang baka magkaroon po ng impact po yung nozzle na walang, yung tinanggal yung nozzle, baka magkaroon po ng quality issue dun sa unit?
Sir, yung nozzle kasi, alam naman natin, ang purpose nun is to suck yung device. Yung sa malalaki kasi, ang nakalagay dyan is yung nozzle. Dito kasi, pag maliit na yung, yung device natin, yun yung design niya, nozzle na maliit. Pero kumukontak pa rin yung device natin, nagre-rest pa rin sa metal. Kaya namin niredesign yun kasi naghanap kami ng alternative solution na para mano natin yung area ng vacuum para lumakas. Pero yung sa tinatanong mo sir na stainless, ganun din siya sir. Bali yung wala naman siyang effect kasi yung material ng is the same naman. Lumalapat din naman po yung device natin doon.
Okay po. So wala po siyang scratches po dun sa unit po na nasasak po nung plunger.
In addition po dun sa sagot namin kanina, bali supported po kasi siya ng bali spring loaded siya.
kino-compensate siya nung spring dun sa loob ng plunger. Kaya kahit malakas yung impact nung plunger dun sa contact, mako-compensate siya nung spring. Then at the same time po, computed po lahat ng namin, ng duct plate namin. Binabase po kasi namin to sa kapal ng device, sa haba ng plunger at saka dun sa haba rin ng spring ng socket.
Yan po, okay po. Thank you.
Okay, thank you. Sa gitna muna tayo. Sa likod muna, Lito.
Good morning, I'm Jonas from Microchip. Yung sa alternative solution nyo na nag-try kayong mag-change ng height, so may pinanggalingang dahilan bakit naging alternative solution yun. Parang hindi, gusto ko lang malaman na ano yung pinanggalingan nyo nung reason bakit nag-evaluate ka o naging alternative solution nyo yung pag-change nung height nung ano.
Bali po sir, ang pinaka main reason namin kasi yun nga nagpo-protrude yung namin, yung pinaka nozzle. Yan yung pinaka main reason kung bakit namin trinay tapos kinompute namin yung based doon po sa pinaka minimum niya na retraction during device pickup is yung 0.2 mm. Kaya yung halos flat na siya during mag-pick up, magdampot ng device po, sir.
I-emphasize ko lang po yung sa sinabi ng teammates ko. Bali po may certain kapal po kasi ang device, tapos yung packet po namin kasi may certain din na haba. Then yung allowable clearance po namin ay 0.2, which is siniro lang po namin. Ibig sabihin magtatouch lang po sa ibabaw ng unit yung pinaka-nozzle niya para safe na safe doon na mapipick up pa rin siya. Hindi po kasi pwede kaming mag-negative kasi baka higupin lang niya na hindi magsisit ng maayos yung device dun sa nozzle tip.
Kasi nakita ko dun sa presentation, ang naging basis nyo is yung statistical analysis nyo na yung nag-jam. Tama. Pero yung at least yung YY analysis or fault tree analysis na nagsabi na bakit yung naging chosen alternative solution nyo para ma-evaluate nyo yung problem ay yung magiging yung jamming. So parang yung pinanggalingan nung mismong bakit nyo ginawa yung solution na yun. Hindi parang gusto kong masanang makuha from your.
Bali po kasi sir, ang pinanggalingan kasi talaga ng problema niyan is yung minsan nahirapan siya mag-pick up, minsan yung hindi niya po madampot. Yun yung tapos mag-place din po. Kasi nga, during pick up po, nagkakaroon ng tilt yung device. Yun yung pinanggalingan ng problem.
In addition po kasi, yung device po kasi namin sa sobrang liit po kasi, 3x3, ang diameter po kasi nung nozzle is 0.8 po yung butas, yung nagsasak dun sa unit. Tapos yung diameter niya is 1.5 lang. Kaya kung hihigupin po niya yung unit, ang tendency po niya mag-flip. Hindi maganda yung seat dun sa tip ng nozzle. Kaya ang naging resulta po, yung baguhin talaga yung design.
Malalim ang pinaghuhugutan, di ba? Okay, last question, Mr. Lito.
Hello, good morning. And thank you for your good presentation. By the way, I'm Lito Balanon. I'm no longer connected with the industry, but I used to be in this industry. My question is, have you involved o merong bang member sa team nyo from the tester or handler manufacturing side or supplier?
Wala po, bali cross-functional team po kaming apat. From sustaining.
Ako sa handler po, Urong.
Ako po sa line sustaining.
Line sustaining pa.
Siguro this is more of a suggestion in the future since dimaik yung methodology ninyo, you involve people outside your organization like the equipment vendor because they are the masters of your equipment. They are the R&D. And
yes,
makakatulong sila. Yun lang.
Bali po kasi kaya po kami doon sir kasi nung ni-involve naman po namin yung pinaka-supplier namin na handler. Yun nga lang yung binibigay namin binigay sa aming solution is parang i-replace yung buong pinaka-plunger pressure. Kaya parang yun.
Sir, in addition po, ako po kasi yung in charge sa nakikipag-community sa supplier. Which ako po yung representative ng hardware. Para ako po yung Tsaka ako rin po kasi yung in charge dun sa pagdidesign ng mga hardware.
Yeah, what triggered me to ask that question is that I've noticed that the team took 25 months to do this study and solution. Kaya sa tingin ko, if you have involved other people like the handler, tester, suppliers or manufacturer, na ituro nila yung mas dapat na gawin in a shorter period of time. Thank you.
Okay po, we will take note po yung suggestion mo.
Actually, nandito yun, yung mga suppliers. Ayaw lang sumagot eh. Sa likod. Alright, sige. Thank you very much.
Moving on, we have the Lord of the Blue Rings from Asurion Techlog Center, Philippines to present iFamily Blue Shadow Defect Elimination.
It was year 2016 when Dark Lord Sauron, living in the Sturgeon Middle Earth, makes a ring. He poured all his evil and his will to dominate the Sturgeon road throughput hill.
The team was composed of cross-functional team for operations, quality, and engineering group. It was formed last February 2017 to work on the improvement of road throughput hill. We focused on quality, and it was categorized into defective machine production and quality built into process. This project is focused on quality built into process, since other items are focused by other group. RTY is consist of A model and I family model. The group selected I family model.
Through this ring, the RTY of Pasuryon will go down. Ha 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 ha!
My precious!
No! That's not yours!
And what is the use of that ring, Sauron?
This will break down the RTY of Pasuryon.
No, I can't understand. And what is RTY?
RTY is a road throughput yield. RTY is calculated by multiplying the yield of each process, while the process yield good units over total input into the process.
No, my precious. And what is the certification plan?
For certification number 1, we can see that the I family from November 2016 to January 2017 has an average of 73.15% versus 80% target, which is leading to negative 6.85% gap. While certification number 2, function station has the lowest price yield with only 84.20% versus 90% target, which is leading to negative 5.80% gap.
So you mean we will focus on function station?
Yes, but upon checking on the function station graph of defect, defective main display is the primary defect. While certification number 4, breaking down the defective main display failure, blue shadow is the top contributor among the defective main display failure. With this, We will spread the blue shadow on the function station, Gollum. My ring! Please spread the blue shadow on the function station.
The ring magically spread the blue shadow on Function Village.
What is the trend of blue shadow, Gollum?
Oh, my precious. There's an average of 0.58% blue shadow failure rate from November 2016 to January 2017. With this, it is an equivalent of quarterly average loss of $36,564 in terms of labor cost of reward failed duties.
Let's continue to spread the blue shadow on the function station, Gollum.
Accidentally, ring fell down from Sauron without knowing. Gollum jumped and get the ring due to his obsession.
My precious, this is my now.
Meanwhile, Frodo and Sam visited the Function Village. They were surprised with the spike of blue shadow.
Sam, I think we have a problem here at Function Station. Look, Sam, from November 2016 to January 2017, top defect is a blue shadow failure with an average of 0.58%, which contributes to low process yield at Function Station. It is an equivalent quarterly average of $36,564.77 in terms of labor cost on rework failed units.
We need to call Gandalf. Maybe he can help us. Gandalf? Gandalf, we need your help.
Yes, I'm here, Brother Sam.
We need to understand the present situation. What is blue shadow?
Blue shadow is a bluish LCD non-conformance that can be seen on the white background of the phone.
How can we detect the blue shadow?
Blue shadow is detected through visual impact inspection.
Where the blue shadow possibles occur?
Based from eye process flow, pour out of the station are the potential contributor of blue shadow defect. These are the KDEX station, assembly, LCM hubs, and function station. With this, I need your help to do YY analysis and check the factor why there's an occurrence of blue shadow defect.
Noted, Gandalf. We'll go to other village.
Frodo and Sam visited other villages to conduct YY analysis. While on their way, they have encountered Gollum.
We will conduct YY analysis here since the occurrence of blue shadow at Function Station.
What is that, Mr. Frodo? Oh, the magical ring. Maybe it can help us in our YY analysis.
Yes, it's a magical ring. So ring, can you help us? Why there is a high failure rate of blue shadow defect?
The ring magically spread the three potential root causes.
No, you should not use that ring. That's mine. That's my precious.
The magical ring continued the root cause.
The magical ring continued to spread the other four potential root causes.
So we now complete our YY analysis. Let's go to Gandalf and show the result.
Wait. Don't you want to validate the potential root cause? Now, Gollum, you should not be helping them. No, but they are now my friends.
Yeah, you're right. We need to validate the potential root cause. Okay, Sam, for the potential root cause number 1, correct attachment of loudspeaker has no significant impact on blue shadow defect occurrence. Team decision?
Not true cause. For the potential root cause number 2, current setup of airgun is not available to use. Decision is
true cause within the team's control.
Oh, and for the potential root cause number 3, cleaning of both sides of metal frame is not stipulated in LTM's document. Our decision is
true cause within the team's control. For the potential root cause number 4, KDEX operator passed the battery with badges based their own perspective. Decision is true cause within the team's control.
For the potential root cause number 5, KDEX operator passed the batteries with part information without measuring and relying on visual inspection only. Decision is true cause within the team's control.
And For the potential root cause number 6, attachment of adhesive to batteries have different results on quality of assembled unit. Our decision is
True cause within the team's control. For the potential root cause number 7, limitation on sample causing different perspective on operators. Criteria disposition. Decision is
True cause within the team's control.
Tell me Okay, now, my friends, can you now validate the contribution of potential causes?
To validate the contribution of potential causes, we need to check the result of each evaluation.
Yeah, right. Based on the result of potential causes controllability, we have 6 true causes. Out of 6 true causes, there were 3 true causes validate as long as hanging fruits and contribute a controllable item based on every result is 100%.
Oh, that's good. That would be a good basis of our objective setting.
We can tell to Gandalf that we can eliminate 100% of blue shadow at Function Village.
Yes, Mr. Frodo, from an average of 0.58% from November to January 2017, we can reduce it to 0% by the end of April 2017.
That's right, my friend. Now, can you give me that ring, Frodo?
No, my friend. We need this ring to check the occurrence of blue shadow. Let's go, Sam. Let's back to Function Village and go to Gandalf for the next phase.
No, my friend. Please wait for me. Oh, that's what I'm telling you. You should not trust them. You should just kill them. No, but I don't know, my friend. My friend, please wait for me.
On the other side, Sam and Frodo already reached the Function Village.
Gandalf, we already finished the validation of potential solution and already identified the objective settings. What will be the next step?
Can now proceed to do PACE, the selection of alternative solution, and proceed to payoff matrix.
For true cost number 4, 2 countermeasures are no-go, and countermeasure is accept the battery with 3.4 to 3.5 mm, which is the normal size of the battery. Team decisions,
go!
For countermeasure of true cost number 5, 5 countermeasures are no-go and 3 countermeasures are go. For tools, evaluate granite and filler gauge to check the warpness and deformation of battery. Team decisions,
go!
Evaluate a plastic tool. Team decisions,
go!
For criteria, accept if warp or deformation is 0.30 mm or below. Team decisions,
go!
For a true cost number 6, 2 countermeasures are no-go and countermeasure is provide guide in attaching adhesive to battery. Team decisions,
go!
We need to go to Mordor Mountain for solution validation. Frodo and Sam travel together on Mordor Mountain for the solution validation. When they get on the Mordor, someone smell the ring.
I smell the fragrance of my ring.
Sauron! For the countermeasure number 4, evaluate the criteria of battery based on size of bulges. Sam, please check the result.
Upon checking, 0 out of blue shadow caused by battery with bulges.
Oh, you cannot decrease my blue shadow. Where's my magical ring?
No, Sauron! For the countermeasure number 5, evaluate the criteria of battery based on size, warpness, and deformity. Provide granite. Provide filler gauge. Provide opening tool. Sam, please check the result.
Mr. Frodo, we already 0 out of blue shadow caused by warp deformed battery.
For the countermeasure number 7, provide guide attaching adhesive to battery. Sam, please check the result.
Mr. Frodo, hold on. We already 0 out of blue shadow caused by overlap adhesive on battery. Frodo, wake up! The blue shadow function station is now dramatically decreased upon implementation from an average of 0.58% to 0% by the end of April 2017. It has 100% improvement. And look, the defective main display failure, it has a good impact on function process yield from negative 5.80% gap on target to negative 4.90%. And the overall impact of iPhone RTY decreased the gap from 6.85% to negative 5.93%. Mr. Frodo, it's over.
volcano erupts, flooding the plain with lava. Sam and Frodo prepare for their deaths, but Gandalf sees a giant eagle and picks them up.
No, my friends, you're here, my friend. And I just realized that the true precious is not the ring. The true precious is not only the tangible benefits, but also the intangible benefits of saving our Mother Earth. My precious.
The team found out the countermeasure to a family. Documentation was made and conducted evaluation for future plan and continued their journey on the next project.
Cuando yo la vi, dije si esa mujer fuera para mí. Perdóname, te lo tenía que decir. Está dura, 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 dura. Que está dura, mano arriba porque tú te ves bien. Está dura, mamacita, te fuiste de nivel. Dura, mira cómo brilla tu piel. Está dura, dímelo cómo es que es. Está dura, yo te doy un 20 de 10. Está dura, dura, dura. Cuando yo la vi, dije si esa mujer fuera para mí.
Okay, thank you very much. Thank you very much. So near. Questions? Mukhang amazed sila. Enchanted. Wala,
From
walang
our judges,
makapagtanong, ah.
meron bang gustong mag-comment po?
Ano yan? Ano yan? Wala kayong questions. Palagay ko. Ayan, may question. Okay. Pag wala daw kasi magtatanong sa last presentation na to, hindi muna tayo magla-lunch. Okay.
Tanong ko lang, nauna yung YY bago kayo nag-objective setting? Tama ba? Kasi nakita ko, objective setting, nag-YY muna kayo bago kayo nag-objective setting. Normally, it's in the first...
From the RTY, kung ano yung lowest process yield sa mga process. Then, saka po kami nag-derive dun sa ano po yung, from the function process, siya po yung pinakamababang process yield. Then, dinipday po namin ano po yung top defects dun sa process, sa function station. So, nakita po namin na defective main display. So, dun po sa defective main display, meron pa po dun secondary defects, which is yun nga po yung blue shadow. So, blue shadow po yung pinaka top defects dun sa function station. Then, ang start po namin, nag-brainstorm po muna kami kung ano po yung mga possible cause based on our FA data, kung ano po yung mga na-conduct na po na previously, ano po yung mga root cause. Then, dun po, nagkamap po kami ng, dun po namin nakuha yung mga potential root causes. Then, after po nun, na-validate po namin na meron po kaming 7 potential root causes. Then, pero 6 na po doon yung true root causes na within our control. Kaya po, doon sa objective setting, sinet po namin yung target namin into 0.
So, nag-review uli kayo ng target nyo after nung YY?
Yes, sir.
Kaya na lumabas, objective setting is after.
Apo. Para meron po kaming basis.
Okay. Part 2 ng innovation, di ba? Innovation yung presentation. Yun, nag-innovate sila ng problem-solving technique. Okay. Yeah. Peter.
Anong team nga to? Lord of the Blue Rings. I have a very tough question for you. I wonder if you'll be able to handle this. Here it goes. How come you're so good?
Oh, thank you, sir.
Congratulations. Very good. Congratulations.
Thank you, sir.
Okay, one more question before we have lunch.
Kaya di makapag-lunch, kaya magka-question ako. So, doon ba sa ako nyo, simple lang, doon ba sa YY nyo, kinonsider nyo yung non-detection and non-conformance?
Opo, sir. Kung mapapansin niyo po, sa YY po namin, andun po yung method sa YY po namin. So during our validation, from our initial data po sa FA, chinek po namin kung ano po yung mga possible root cause. One of the potential root cause is yung pong criteria namin ng battery bulge is, nakalagay po sa procedure namin is, pag po small yung bulge, accept. Pero kapag big po yung bulge is reject, which is subjective. So, ang nangyari po sa line po namin, nakita namin sa mga operators na meron po silang misjudgment dun sa criteria since wala po kaming, initially wala po nakaset talaga na measurement. That's why nag-collect po kami ng ng 100 batteries. Then nakapag-come up po kami ng mga measurements, dun pinaran po namin sa assembly.
Okay, thank you very much. Another round of applause. And of course, after this, we all deserve a break.
There you...
Ingat talaga ng bawat isa sa ASEP, sigurado ka.
Lupit ng mga projects na pinakasa, lahat ng products gumaganda.
Delivery, cost quality, saan ka man maasahan. Quality ang iyong lalapit, nag-iisipan rin, nagpapaluma ito. Gamit ang QC tools, with the CCA, for more improvements, inside at your evaluation.